In this video, I'm going to work through a couple related rates problems associated with distance. I'll work through this problem, which is in your note package, and one from your homework. Okay, this problem says that a man begins walking north at a speed of 1.5 meters per second, and a woman starts at the same point P, and she begins walking west at a speed of 2 meters per second. At what rate is the distance between the man and the woman increasing 1 minute later? So let's illustrate what we know. Both the man and the woman start at point P. The man's going to walk north, the woman walks west, and we'll let this line represent the distance between the man and the woman. Let's let X represent the distance that the man walks north, and Y will represent the distance that the woman walks west. And let Z represent the distance between the man and the woman, and we're going to calculate that distance after 1 minute. Now, we have the rate at which X is increasing with respect to time. So the man is walking north at 1.5 meters per second. So dx dt would be 1.5. The woman is walking west at a speed of 2 meters per second. So dy dt is going to be 2. And what we're going to be calculating with this problem is dz dt. In this problem, because it's asking us to calculate after 1 minute, we're actually able to figure out what x is, y, and with a bit of work, we're going to get z. So remember that x represents distance, and we could calculate the distance that he travels after 1 minute. So 1 minute is 60 seconds. If he travels 1.5 meters every second, in 60 seconds, how far would he travel? So 1.5 meters every second, that would be 60 seconds times 1.5. He would be traveling 90 meters, or he goes a distance of 90 meters in 60 seconds. The woman travels at a rate of 2 meters per second. Okay, in 60 seconds, she would be going 2 times 60. She'd go a distance of 120 meters. We could easily now calculate z using Pythagorean's theorem. So z squared is equal to x squared plus y squared. Z squared, so the distance between the man and the woman after 1 minute, would be 90 squared plus 120 squared. 90 squared is 81,000. And 120 squared is 14,400. If you add up those two distances or numbers, we're going to get 22,500. And the square root of 22,500 is 150. Now that we have z, we're able to calculate dz dt. And how we're going to do that is we're going to implicitly differentiate both sides of my equation with respect to time. So we're going to take the derivative of each side with respect to time. The derivative of z squared is 2z dz dt. The derivative of x squared is 2x dx dt. And the derivative of y squared is 2y dy dt. Let's divide out 2, and we'll input our numbers. So z, which is what we just calculated, is 150. We're trying to isolate, or we will be trying to calculate dz dt. X is 90, dx dt was 1.5, y was 120, and dy dt was 2. 90 times 1.5 is 135. 120 times 2 is 240. $135 plus 240 is 375. So I have 150 dz dt is equal to 375. If you divide both sides by 150, you will isolate dz dt. And we will get an answer of 2.5. And the units will be the same as dx dt or dy dt, so meters per second. Okay, let's look at a very similar problem to this. So this one, two cars begin moving from the same starting point at noon. One car travels east at 60 miles per hour and the other car travels north at 80 miles per hour. How fast is the distance between the two cars changing at 3 p.m.? So just like within the first example, we'll start out by putting what we know into a diagram. So it says the first car from the starting point, where does he travel? He travels east at 60 miles per hour. So that's going to be car 1. Car 2 travels north at 80 miles per hour. And this line will be the distance between the two cars at some point. So let's let x be the distance that the first car travels. We'll let y be the distance that the second car travels, and z is going to be the distance between the two cars at 3 p.m. Just like the problem before, I know the rate at which x is increasing. So the first car, which will be x, is traveling at 60 miles per hour. So dx dt is equal to 60. dy dt, which would be the second car, is traveling at a rate of 80 miles per hour. And what we're going to calculate in this problem is going to be dz dt. Again, as with the previous problem, we're able to figure out the distance that the car traveled, the first car, the second car, and using Pythagorean's theorem, we're going to be able to get the distance between those two cars. So what it says is it says that the cars began traveling at noon. And it says how fast is the distance between the two cars changing at 3 p.m. So that's 3 hours. We're able to calculate the distance that each car traveled in 3 hours. So the first car travels 60 miles in 1 hour. So in 3 hours, 60 times 3 is 180 miles. The second car travels 80 miles per hour. So every hour it travels 80 miles. So if it goes 3 hours, 80 times 3 is 240 miles. Let's use Pythagorean's theorem to calculate what z would be. So the distance between those two cars 3 hours later. So x is 180, y is 240, $180 squared is 32,400, and 240 squared is 57,600. Z squared is equal to 90,000. And square rooting 90,000, we will get the distance between those two cars 3 hours later. It's going to be 300 miles. So now that we have Z, we can calculate dz dt. And again, how we're going to do that is we're going to implicitly differentiate both sides with respect to time. So the derivative of z squared is 2z dz dt. The derivative of x squared is 2x dx dt. And the derivative of y squared is 2y dy dt. Again, let's divide everything by 2. We calculated z to be 300. We want dz dt. X was 180 miles, and the rate dx dt was 60. And y is 240 miles, and the rate of y dy dt was 80. 180 times 60 will give you 10,800. 240 times 80 will give you 19,200. So if you added those two numbers together, we would have 30,000. And then on the left-hand side, I have 300 dz dt. Okay, let's isolate dz dt by dividing both sides by 300. And I'm just going to cancel 2 zeros here and 2 zeros here. 3 divided by 3 is 1, so a 1 with 2 zeros, 100. So dz dt is 100, and our units miles per hour. And that would be the answer.